Hello everyone, welcome back to the Atharva Gate Academy. Myself Chinmay Daduk, and today in this video we are going to discuss moment and couple, and we will also discuss some example of load that are applied to different types of body. So let us start. First of all, we are going to discuss moment. What is moment? The turning effect of a force applied to any rotational system, or we can say any system at a distance from the axis of rotation, is called as moment. Now let's say we have this system in which here there is a point about which this body can rotate. Let's say we apply here force in this direction. Let's say it is P. Here when we apply this load P on this body is going to be rotated about this point. If this body is fixed, then if this body is fixed, then there will be also a turning effect by this load P. Now here, where will be the axis of rotation? The axis which is passing through this point and which is perpendicular to the screen is called as axis of rotation, because this body is going to be rotated about this axis of rotation. So that turning effect by this force is called as moment. Now how to find the value of moment? Moment is denoted by m. The moment is equal to magnitude of force multiplied by the perpendicular distance between its line of action and the axis of rotation. So here what is the value of load? Value of load is P, and multiplied by, we have to take distance between this line of action of this load. Here line of action of this load is this line. Axis of rotation is at this point. So we have to take perpendicular distance between these two lines. So it will be this distance, and it is perpendicular, right? Let's say this distance is x. So here moment will be P into x. It is very simple that moment by any load applied on the body is equal to value of that load and perpendicular distance between line of action that load and the point about which this body is going to be rotated, or the point about which we are going to find moment in this body. Now let us discuss couple. What is couple? A couple is pair of forces equal in magnitude and opposite in direction, means oppositely directed. So let's say we have this body and we apply load in this direction, and at this point we apply load in this direction. This is the pair of forces. It should be equal in magnitude. So let's say value of both the load is P. The direction of both the load should be opposite. So here you can see that this load is in the downward direction and this load is in the upward direction, and this both load should be parallel. Let's say here total distance between this both load is L. Now let's say we want to find out couple about this point. We can consider that this body is going to be rotated about this point. We can also consider an axis which is perpendicular to the screen and which is passing through this point, which will be axis of rotation. Let's say distance from this point to this load is A, and distance from this point to this load is B. Now how to find value of couple? Couple can be considered as a sum of moment applied by this load P. So let's say value of couple C, or let us take it moment M, is equal to value of moment by this load P, which is in the downward direction, plus value of moment by this load P, which is in the upward direction. So what will be the value of moment by this load P here? It will be load into perpendicular distance from this point. So it will be P into B, distance between this is, plus what will be the moment by this load? It will be value of load into perpendicular distance from this point. So it will be P into A. If we take P common, then it will be B plus A, or we can say A plus B. And what is value of A plus B? A plus B will be total length of this body, that is L. So it will be P into L. So value of couple will be P into L. That is value of this load P into total distance between this pair of forces, that is L. So I hope it is clear to you that what is moment and what is couple. Now we are going to understand the direction of moment. Let's say we have this body and we fix the left surface of this body. Here we will take this direction as a x direction, this direction as a y direction, so this direction will be z direction. So in this body, this plane will be plane perpendicular to the z axis. This upper plane will be plane perpendicular to the x axis, and this plane will be perpendicular to the y axis. Let's say we apply a moment in this plane which is perpendicular to the z direction like this. Due to this moment, this body have tendency to rotate about this z axis. So this moment is called as moment about z axis, which is mzz. Now if we apply moment in this upper plane like this, then due to this moment, this body have tendency to rotate about this x-axis. So this moment is called as mxx. And if we apply moment on this plane in this direction, then this body have tendency to rotate about this y-axis. So this moment is called as moment about y-axis myy. Now to define the direction of moment, we are going to use right hand thumb rule. As per this rule, we have to curve our finger in the direction of moment applied to the body, and then the thumb shows the direction of that moment. Here, this moment mzz is applied in the anti-clockwise direction when we see from this side, right? So if we curve our fingers in the direction of this moment, then it will be like this. I hope that you can imagine that. If we are going to curve our fingers in the direction of this moment, then our direction of thumb will be this, and this will be the direction of moment zz. So I hope you understand that how to take the direction of moment. Now let us find the direction of this moment mxx. Here this moment is in the anti-clockwise direction when we see from this direction. Here also you can see that this moment is in anti-clockwise direction when we see from this side. So we are going to curve our fingers in the direction of this moment. So you can imagine that our fingers will be curved in this direction. And then the direction of thumb is in the upward direction, which will show the direction of this moment mxx. And similarly, if you find the direction of moment myy, then it will be in the direction of this y direction. So I hope you understand that how to find the direction of moment. We are going to use this direction of moment in the subject of theory of machine, but it is better to understand it right now. We know that there will be centroid of this body somewhere here, and axis which is passing through this centroid and along the length of this body will be longitudinal axis, and axis which is perpendicular to this axis will be transverse axis. So here this z axis will be longitudinal axis, and this x axis and this y axis will be transverse axis. Remember one thing, that moment about x axis and y axis will produce bending moment in the body. Means we can say that moment about transverse axis of this body will produce bending moment in the body. And we will also understand that bending moment will produce normal stress in the member. And also remember one thing, that MZZ means moment about Z axis produces twisting moment in member. Means here moment about this longitudinal axis of this body will produce twisting moment in this body. And we will also understand that twisting moment produces shear stress in the body, or we can say in the member. Now we are going to discuss the effect of different type of forces acting on this beam. We will find the value of axial load, shear force, bending moment and twisting moment produced in this body due to different types of load applied on this body. Here we have this body which is actually a beam like this, but I have already drawn the line diagram for this beam. So the line diagram of this beam will be like this. Here this beam is fixed at the left hand side. Here this axis is going to be the longitudinal axis for this beam, and here there will be a centroid of this body. Now if we apply load in this direction, let's say having value P, then it will be axial load for this beam. So here load is axial load. It is an axial load because direction of this load is along the longitudinal direction of this body and it is perpendicular to the surface of this body. Here this beam is like this and there will be a surface of this beam like this. So it is actually perpendicular. And it is also passing through this centroid. Now we are going to find effect of this axial load on this beam, and we will find what is the value of axial load, what is the value of shear force, what is the value of bending moment and what is the value of twisting moment on this beam due to this load P. First of all we will find value of axial load. Here directly we can see that value of this axial load will be plus P. Here I have taken it positive because it is acting away from the body, means it is tensile in nature, and we know that tensile load is taken as positive. We have already understand that load which is perpendicular to the surface is called as axial load and load which is parallel to the surface is called as shear force. Now here surface of body is like this. So this load is applied perpendicular to the body. It is not parallel to this body, means it is not parallel to this surface. So here value of shear force will be 0. If this load was applied in this direction like this, then there will be shear force due to this load. But right now it is only in this direction. Now let us take this point as point A and this point as point B. Now we have to find value of bending moment and twisting moment in this body due to this load P. Let's say we want to find out moment about point A. It is MA. Now how to find moment about point A? We know that moment about point A is equal to value of this load into perpendicular distance between this point and line of action of this load. Here distance between this point and line of action of this load is 0. So value of moment will be P into 0, means it is equal to 0. And I have also told you to remember that moment about transverse axis produces bending moment in the body and moment about longitudinal axis produces twisting moment in the body. Here there is no any moment in the body, so value of bending moment and twisting moment will be 0. Now let us apply eccentric axial load on this beam. Load is eccentric axial load. We know that eccentric axial load is perpendicular to the surface along the longitudinal direction and it is not passing through the centroid of the body. Here this is the longitudinal direction, there will be a centroid of the body, and here this is the surface of this beam like this. Let's say we apply load in this direction having value P and it is having distance E from this longitudinal direction. In this case, it will be eccentric axial load. We can also show this load by a line diagram. It will be like this. Here this is the extension and in which we apply load P in this direction. Let's say this point is point A, this point is point B and this point is point C. Now we are going to understand that how to find all this value of axial load, shear force, bending moment and twisting moment in this case when we apply eccentric axial load P. To find out all this value, first of all we have to transfer this P load on the centroidal axis of this body, or we can say longitudinal axis of this body. I magnify this figure here. Here there is a same beam AB, and this is the extension of this beam, and at point C we apply load P which is having distance E from the longitudinal axis. Now how to transfer this load P at this point? For that we will apply two equal and opposite load at this point. One load will be in this direction having value P and second load will be in this direction having value P. Now here if you see that this is the line that is BC, and at this point there is load P in this direction and at this point there is load P in this direction. Distance between these 2 points is E. So we have discussed the couple that two force which is equal in magnitude and opposite in direction and having some distance between them is called as couple. So this two load is going to be produced couple in this body. So what will be the value of couple? Couple means we can also say that moment will be equal to value of this load P into distance between these two load, that is E. So here this two load will produce couple in this body which will act at this point. Now I am going to remove these two loads. And instead of this two load there will be a couple which will be in this direction. Value of this couple M will be P into E. And also this axial load P will be left at this point B. So finally this eccentric axial load is converted into one axial load P and one moment at point B. Here this moment is in clockwise direction because here this couple have tendency to rotate this body in clockwise direction. So from this direction of load you can see that direction of moment will be clockwise. Now we can find out all these values. What will be the value of axial load? Here you can see that there is value of axial load is P. So it will be P. And it is tensile in nature, so it will be positive. Now how to find shear force? We know that load which is parallel to surface is called as shear force. Here there is no any load acting parallel to this surface of body. So value of shear force will be 0 for this surface of body. Now here you can see that there is moment applied on this body. Value of this moment is P into E, and this moment is not about the longitudinal direction of body. It is about transverse axis of the body. Means it is about direction which is perpendicular to the screen of this body. We know that moment which is about the transverse axis of body will produce bending moment in the body, and moment about longitudinal axis of the body will produce twisting moment in the body. Here this moment is about the transverse axis of this body. So here value of bending moment will be P into E because this moment will be bending moment for this body, and there is no any moment about longitudinal axis of this body. So what will be the value of twisting moment? Twisting moment will be 0. So I hope that you understand that how to find these all four values. Now in third case, we are going to apply a point load at this end in the downward direction. This load is applied at the perpendicular direction to the longitudinal direction of this body, and it is parallel to this surface of the body, so it will be considered as transverse load. And it is in the vertical direction, so it will be vertical transverse shear load. Now we are going to find what is the value of axial load, shear force, bending moment and twisting moment due to this load P. First of all, we are going to find value of axial load. We know that axial load is perpendicular to the surface or it is parallel to the longitudinal axis. But here this P load is parallel to the surface and perpendicular to the longitudinal axis of this body. So it is not a axial load. So here value of axial load will be 0. Now what will be the value of shear force? We know that load which is parallel to the surface or perpendicular to the longitudinal axis is called as shear force. Here this load is perpendicular to this longitudinal axis of this body. So this load is considered as shear force. So here value of shear force will be P. Now due to this load, what is the value of bending moment and twisting moment in this body? Let's say this point is point A and this point is point B. At point A, we want to find out value of moment M. So let's say it is MA. What will be the value of moment due to this load P at this point A? We know that moment is equal to value of load into perpendicular distance between this point and line of action of this load. So value of bending moment MA will be P into this distance, let's say it is L, so it will be P into L. Here moment about point A will be in this direction. This moment is about the transverse axis of this body. It is not about the longitudinal axis of the body. And we know that moment which is about the transverse axis of body is called as bending moment. So here this moment will be bending moment. It will be P into L. And this moment is not about the longitudinal axis. So here value of twisting moment will be 0. Right? Now before going to understand next case, we have to understand two direction. These are the two symbols of direction. Here this symbol shows the direction which is perpendicular to the screen and which is going inside the screen. And this symbol shows the direction which is perpendicular to the screen and which is coming out of screen. We can also understand this in another way. Let's say we have one arrow like this. Here at this end there will be a point of arrow, and at this end if we see from this side, then you will see this type of cross. If this arrow is going inside the screen, then you will see this cross at the end of this arrow, and if this arrow is coming out of the screen, then you will see this point of this arrow. And the direction of arrow will show the direction of load. So by that you can understand this symbol. Now let's say here we apply a load which is in the direction perpendicular to the screen and which is going inside the screen. Let's say here value of this load is P. Now what will be this load? This load is perpendicular to the longitudinal direction of this body and it is parallel to the surface of this body at the end. So it will be a transverse shear load and it is horizontal, so we will write that it is horizontal transverse shear load. Now we are going to find axial load, shear force, bending moment and twisting moment by this load P. Now I think that you can understand that this loading condition and this loading condition is nearly same. Difference is only that here this load is in vertical direction and here this load is in the horizontal direction. So actually value of all this load is going to be same for horizontal transverse shear load. So here value of axial load will be 0 because this load is not parallel to the longitudinal axis, value of shear force will be P, because this is the perpendicular to the direction of longitudinal axis. Value of bending moment MA will be P into L, and here this is the point A and this distance is L, and twisting moment will be 0, right? Now in next case we are going to apply a load of value P in the perpendicular direction to the screen and which is going inside the screen. It is applied at the point C, which is extended from point B, and here this point is point A. Means actually here the beam is like this and we apply this point load at this end. So in that case, what is the value of axial load, what is the value of shear force, what is the value of bending moment, and what is the value of twisting moment? Here you will be able to understand that this load is actually eccentric transverse shear load, because the direction of this load is perpendicular to the direction of this longitudinal axis. This load is applied parallel to the end surface of this body, and also it is not passing through the centroid of this surface. It will be here. So it will be eccentric transverse shear load. I hope that you are able to understand it. If you are not understanding it, read the eccentric transverse shear load from the notes that I have discussed in the previous video. Now in this case we are going to find value of axial load, shear force, bending moment and twisting moment. To understand it properly, let us take this 3D figure. In this figure, here this beam is fixed at the left hand side. Here there will be the center of this body, and here this point will be center of this surface. This point will be point B, and here center of this surface will be point A. Here let's say this point is point C, on which we apply this P load. This P load is applied in this direction at this point C. Now this load which I saw in the blue color is having value P, and we want to transfer this load P from point C to point B, because to find all this value we want this load to be applied on the central axis or on the longitudinal axis of the body. To transfer this load we will take two equal and opposite load applied at this point D. Let's say at this point one load is applied in this direction and second load is applied in this direction. Value of both the load is P, and let's say distance between this point C and B is E. So here this distance will be E. Now you can see that these both load are having same value P, and it is in the opposite direction to each other, and also these both are parallel to each other. So we know that this type of loading condition produce couple in the body. So here what will be the value of couple? Couple, or we can say moment, will be equal to load P into E, that is the distance between this load. So now this two load will be removed, and instead of this two load there will be a moment in clockwise direction like this. This moment is parallel to this plane, means this moment is applied to this plane. Let's say this moment is M, and value of this moment will be P into E. And yes, this P load also will remain at this point B. So finally this P load is converted into one moment and one transverse shear load. This P load is same as this case. So here what will be the value of axial load? As you can see that there is no any load which is parallel to the longitudinal axis of this body, means there is no any load like this. So here value of this axial load will be 0. Now what will be the value of shear force? As we see in this case, value of shear force will be P, because here this load is perpendicular to the longitudinal axis of this body. So here shear force will be P. Now this moment is about the longitudinal direction of this body. and we know that a moment which is about longitudinal axis is producing twisting moment in the body. So here this moment produce twisting moment in the body, so value of twisting moment will be P into E, and there will be no any bending moment because there is no any moment which is about transverse axis of the body. So here value of bending moment will be 0. So I hope that you understand all this type of loading condition and how to find axial load, shear force, bending moment and twisting moment in these all the cases. Fine? Now today we will stop here and continue in the next video. In next video we will discuss some more example which are similar example as we have discussed in this video. Before going to understand examples in the next video, carefully understand all the examples and all the cases that we have discussed in this video. Then and only then you will be able to understand next examples. Okay? So we will meet in the next video. Till then, stay motivated and happy practicing.